Saxon's Calculus Lesson 1 is about deductive reasoning, the contrapositive, and converse and inverse. Again, this should be a review of concepts that you learned in trig. However, there is a minor variation, and I'll get to that in just a bit. So deductive reasoning begins with some terminology here, which says inductive reasoning, not the deductive reasoning that we're talking about, but inductive reasoning is a process of determining or formulating a rule by using other observations in the real world, basically, or making a guess. A deductive reasoning is different. It is the process that uses step-by-step rules that get you from one place to another conclusion, and that's deductive reasoning. Deductive reasoning is what you see in the geometry proofs. Then they go into the ancient Greeks formalized the study of logic with their use of syllogisms in their investigation in deductive reasoning. So what is that syllogism? It's a formal reasoning process in which a conclusion is inferred from two statements that we will call premises. So in this example, these two are my premises, and then I'm going to make a conclusion. The first statement is called the major premise. The second statement is the minor premise. And then, they're talking about categorical propositions. They place things in categories. We will concentrate on premises that are called universal affirmatives, a lot of wording, to get to the major premise and the minor premise. And the key takeaway from those is the fact that the major premise, no matter what it is, for that particular problem, we are going to consider it to be truthful. Whether it actually is or not is irrelevant to us. The major premise is the rule for that particular example. And then they make a big deal on the next page that we are not working to say whether this argument, which is their statements and their conclusion called an argument, whether they are valid or invalid. They're just saying, do they fit the right pattern? So let's figure this out. So in this major premise, all men are mortals. Okay, yeah, I grant that in the real world that's true, but I don't care one way or the other. For this problem, all men are mortals. Okay, Aristotle is man. Does it then flow that Aristotle is mortal? Yes. So this is a valid argument, and it happens to be truthful as well, but I don't care about that. So now let's go to the next one. Sum of exterior angles in a convex polygon, meaning all the points are coming out. So is the sum of all of the outside angles 360 degrees? Yes, but I don't care about that. But for this problem, yes, absolutely. Triangle ABC is a convex polygon. Okay, so it fits the first half. So can I conclude that the sum of the exterior angles of triangle ABC are 360? Yes, that is a valid conclusion. The argument is valid. Okay, how about all frogs are green? Now, I have a problem there. Not all frogs are green, but even though it failed in the truthfulness of the statement for the real world, I don't care. For right now, all frogs are green. Henry's a frog. Can I conclude that Henry is green? Yes, that is a valid argument. Now, if it rains, I will go to town. It didn't rain, okay? My only reality that I have is if it rains, I'm going to town. I know nothing about a reality in which it doesn't rain. So my conclusion was I didn't go to town. I don't know, because I don't know what happens when it doesn't rain. My world doesn't tell me. It only talks about if it rains, I'm going to town. So this is an invalid argument because it doesn't flow. Now, example 1 gives us some to figure out on our own. So I didn't write these out. All normal dogs have 4 legs. So dogs yields 4 legs. That dog has 4 legs. So can I conclude that the dog is normal? All dogs have 4 legs. This dog has 4 legs. Therefore, the dog is normal. All all I know is that dogs have 4 legs. That dog has 4 legs. Here's my problem. All I know is that dogs have 4 legs. It just said, no, all normal dogs. Maybe that'll help. All normal dogs have 4 legs. That dog has 4 legs, but I only know about normal dogs. So I cannot conclude that the dog is normal. It's invalid. It did not fit. If the minor premise had talked about normal dog, then I could have drawn a conclusion. Okay. Example 2. All boys are good. Boys yield good. That child is good. Can I conclude that the child is a boy? All I know is that boys are good. If this had said, I have a boy, then I could conclude it is good. But this does not help me. So again, the argument is invalid. It also doesn't fit in the real world. Example 3. Is the following argument a valid argument? All chickens have 3 legs. Henny Penny is a chicken. I have a chicken. Can I conclude that Henny Penny has 3 legs? Chicken has 3 legs. Yes, even though it does not work in the real world, it is a valid solution. Now, we move into part B, the contrapositive. Okay, so in all of these, my reality is the major premise. It's all I have to work with. However, the contrapositive is when I take my first statement and I reverse its order. So I put the conclusion first and then what it said as the conclusion, and I negate them. So last year I used a negate symbol in front of. So I'm saying P yields Q, not Q yields not P. That's the contrapositive. In this book, they will change the squiggle in front to a dashed line on top. And that's the major change here that is new for you. If the contrapositive changes my reality enough that I could then use the minor premise to draw the conclusion, I'm allowed to do that. But if the contrapositive doesn't help me resolve it, then I cannot change it from invalid to valid. In part C, they talk about converse and inverse, which are the flipping or the negating, either way, and I'll get to which one is which when I talk about part C. They could be valid or not valid. They do not help me fix my overall statement. So let me go back to example 4. Is the following argument valid? All non-athletes are vegetarians. Jim is a non-vegetarian, so he is not a vegetarian. Can I conclude that Jim is an athlete? Now, my reality only talked about non-athletes yielding vegetarians. And then I want to talk about not being a vegetarian. So let me see if the contrapositive will help unlock this. So that would mean I'm saying non-vegetarians yields athletes because I've reversed it. Vegetarians has gone first, athletes has gone second. I went from not being an athlete to being an athlete, from being a vegetarian to not being a vegetarian. So now, oh, you know what? I'm going to change that to match the not, so you can see it matches what I had from before. So now I have the same thing. Does this work? Not being a vegetarian means I am an athlete. Not a vegetarian, yes, athlete is a valid conclusion, so that is valid. So you see how doing the contrapositive can unlock my original statement into a form that I might be able to answer. Now, let's get over to converse and inverse. These are what they call are conditional. They might be true, they might not. It just depends on what is truthful in the real world application, basically. So I'm going to use their statement here. If an animal is a rabbit, then the animal is a fast runner. Okay, so we're saying that's true. The converse of that is where we say if an animal is a fast runner, then the animal is a rabbit. Well, I can think of other animals that are fast that aren't rabbits, so it's a false statement in the real world. But what they did was they flip-flopped it. So instead of going P yields Q, the converse is Q yields P. You've just flip-flopped the order. The inverse is, as you would expect, if the original statement is P yields Q, it's going to be not P yields not Q. So I didn't reverse the order. It's not the contrapositive, but I am negating the statements. Yes, and they are beginning to change you over to in the boxes these statements. Now, I will stop and clarify something here. They are using their conclusion as an if-then statement, and I'm going to come back to that here in a second. So if you flip to page 18, you see we've got a conditional statement, and then it's contrapositive, and then they do its converse and its inverse. So the statement says, if I have a square, then I have a quadrilateral. And in their if-then piece of that box, they did P yielded Q. And then the contrapositive is flipping it and saying, if I don't have a quadrilateral, I don't have a square. So they're not Q yielded not P. So let me go back to those actual statements and see if they're true or false. If I have a square, do I have a quadrilateral? Yep, that's true. If I don't have a quadrilateral, I can't have a square. Yes, that's true. Now let's try the converse. Just flipping the statements so that it's Q yields P. If I have a quadrilateral, it's a square. Well, no, it could be a rectangle and still be a quadrilateral. That's a false statement. What about the inverse, where I not P yields not Q? So if it's not a square, it's not a quadrilateral. Can I think of an example where, oh yeah, a rectangle. A rectangle has to be a quadrilateral, so it's not a quadrilateral, so that's false. So in those, it does not work because the converse and the inverse didn't really help me. They created false statements. Now, in their next boxed set, they say the conditional statement is sides have equal lengths, then angles have equal measures. So if the sides are equal, the angles are equal. That's truthful. All right, the contrapositive, the angles do not have equal measures, the sides do not have equal lengths. That's also truthful. Great. Now what about the converse? Angles have equal measures, then sides have equal lengths. Yes, that's true. Now the inverse. Sides do not have equal lengths. Angles do not have equal measures. Yes, that's true. So when all of the statements are true, it creates an if-then. No, my originals were if-then. It creates an if and only if, which they abbreviate to IFF, if and only if. And then in the symbols, this is a P yields Q, but the arrow goes back and forth. It doesn't matter which way I'm writing it. So if I'm seeing a double arrow, it's saying every part of the statements, the contrapositive, the converse, and the inverse all have to work. And it would also mean the same thing if I said not P, if and only if, not Q. Same thing. All four of the statements will have to be truthful.